Let's see how can we detect cycle in an undirected graph using BFS. Okay, so let's see the given example. So we are given a graph here. Here we can see there is a cycle between 0, 1, 2. There is a cycle here, and we in the question they are asking us to return true or false. If there is a cycle, we need to return true. If there is no cycle, we need to return false. Okay. So how can we solve it using BFS? Let's see. So I have written the adjacency list for the given graph. See. So let's think of the approach in this way. So we are given an undirected graph. So let's try to think this as a directed graph like parent and child concept. Let's start with 0. Since 0 is the first one, let's assume -1 is its parent. -1 is the parent of 0 and we are at 0. Okay. Let's go to neighbor nodes of 0. What are they? 1 and 2. Okay. So from 0 I can visit 1 and 0. Parent equal to 0. Okay. Now try to visit 1. Okay. So when I try to visit 1, um, I mean when I try to visit neighbors of 1, what are they? 0 and 2. 0, which is parent of 1. So we don't go further. 2. So if you observe one thing, we have already visited 2. But again we are trying to uh, go to 2. Earlier we visited 2 through 0. Okay. But again we are visiting 2 through 1. This occurs only when there is a cycle. Here you can observe from 0 again to 1 again to 2, and again I am able to go to 2 through 1, which means there is a cycle here. So I will make use of this concept and I'll return true or false. Okay. Let's see how can we write code for this. So we are given an edges. We need to form edges and subs for using this. So I'm forming the adjacency list that add up here. So I have my adjacency list. And what else? I need a visited array. Visited. Of P. I have my visited array and all are equals to false. So let's insert this. So let's have a pair class to store row and objects in row and column files. Okay. So I'll add 0 first, and its parent is -1 since it is the first node, and I'll mark 0 as visited. Let's see. So we iterate until the queue is empty. Pop the friend element in the queue to open. So my current row will be current dot row, and my current column will be current dot column. I have this. I check its neighbors. Current neighbor. Sorry, my bad. We don't need this. You can directly. I mean, this is a different thing. I have written row column. It is node and parent. Okay. So now my current node, current node, current node parent equal to current dot parent. Okay. So what will happen is assume right now 0 is my current node and parent is minus 1. So I'll check 0 neighbors. So that means my current node is becoming a parent for its neighbor nodes. Okay. Don't get off current node. It's getting all of its neighbors, and I'm checking if it is visited. I mean, if it is not visited, what I'll do is I'll mark it as visited, and I'll add this into my queue. My current node is neighbor and its parent is parent node. It is if it is not visited, I will use this. If it is visited, so in our case, assume it is 2. When I try to go to 0 neighbors, uh, I mean I can go to 1 and 2. So 2 is visited already. So when I try to check neighbors of 1, it has 0 and 2. So 0 is already visited, 2 is also already visited. 0 is already visited because it is one parent, so no issue. But 2 is visited, that means there is a cycle like this. Visited. And if neighbor not equal to parent, not parent, then that means a cycle like this. And send the like return false. That's it. So I haven't defined it here. So this current dot pair, like let's try to submit this. Maybe got one wrong also. So we're missing something. Let's see. So yeah, one thing we see is what if we have more than one component? So then in that case our code will fail. Let's try to write code such that it can handle multiple components. Okay. Try to write BFS in a separate function. After forming this, after doing this, I just think this. If not visited, of I. Then to BFS. If I get 2 in BFS, I'll return 2. If I got false, I'll check other cases. Let's copy this BFS to here. Okay. So what else I missed? That Q pair, Q moving to this stuff. Instead of let's current node. Let's send the required values. What I need to send. What is my current node? What is my adjacency list? How many nodes are there? My listed array. So these are enough. Yeah. Boolean listed and so this list list int v. Okay. Listed of node equal to. At the end we need to return true or false. I'll return true here. If I found no cycle, at the end I'll return false. So yeah, I need to add this. We are going to add of new pair of from comma minus. Yeah, this should work. Yeah, let's try to submit this. So yeah, it got accepted. Now let's analyze time and space complexity. Let's see time first. So I'm iterating through edges. How many edges are there? Those many. You can think of it as big of E, number of edges, plus this one big of V. So we are doing BFS, and at max we will, since it is an undirected graph, we will big of 2 to E, number of edges, those many. Space, let's see what is the space we're using. So we are using one space where adjacency list. So I don't think we can still mention it, but I don't think I mean it's still okay not mentioning about adjacency list. Now we're using extra visited and Q, so it will be big of V and Q at max. So we can store all the nodes big of V. So these are the time and space complexities. Yeah, that's it. Thank you.